Hope you're having a great Halloween evening. It's been fun over at my house. We typically do a fire pit out in the front and let all the kids stop and get warmed up and have some hot chocolate and make roast some marshmallows and stuff like that. And that's what's going on in front of my house right now. Kind of fun. But tonight we're going to dive into some really interesting topics. Some of the stuff that we're going to talk about tonight are some of the things that inspire me to do a good job as an engineer, as a software developer, because we kind of start to see in Express as an example. Just keep in mind that Express is a system that that was developed by developers, by other people that are just like us, the software developers, and the ability to have foresight into how people are going to use the system that you're creating is really important. It's really powerful. And that's what we're going to get a chance to kind of experience, some of the really cool features of Express and the way that it was laid out. It can be a little bit daunting because it's a little bit, I don't want to say complex, but you have to get familiar with the way that it works. But once you do, it's really pretty cool. Express is a system that is known as something that is unopinionated. There are systems and frameworks and APIs out there that are very opinionated, meaning that in order for you to use them, you have to structure your code and your application in a particular way. And you have to do things their way in order to use their system. Express, as well as many other systems and frameworks, is designed to allow you to use JavaScript and Node the way that you typically would. And we're going to get a little bit of a peek towards the end of the class tonight at it's something that kind of expresses that idea that we're not really locked into a particular way of doing things. We can take full advantage of JavaScript and Node as we want to. We're going to use Slido again tonight, so I'm going to drop the link to that in Slack. So if you want to jump into there, that's where we'll take questions. And then we'll also might do some polls in there. We'll see if we've got time to do that. All right. So tonight, server-side routing with Express. Our focus tonight is going to be on, it's called server-side routing. If you remember back to your work with React, you dealt with routing there a little bit. And we talked a little bit about route parameters yesterday, routing parameters, and how they're very similar to parameters and routes in React. So we're going to talk a little bit more about routing tonight, and we'll dig into some detailed features of that. We'll take a look at, we've already talked about or looked at how we can use parameters in a URL to get data into our application on the server side from the client. We've also looked at how we could use the request body to do that. Tonight we're going to also take a look at query parameters in the URL and how we can take advantage of that to allow users of our API to specify parameters around how we should process their request. We're also going to talk, in fact, we're going to start off talking about REST and what REST is and what it means. And we'll get a really quick peek at one of the benefits that we get from developing a REST-like API. And also we'll learn a little bit about the difference between what it means to be REST-like and to be fully RESTful. You'll get some kind of industry insight from my perspective, having designed APIs and deployed them in situations where we've got hundreds of thousands, if not millions of people that are using it. Very important to get the design right depending on who your audience is. So we'll talk a little bit about that. And then lastly, we're going to talk about Express routers as a feature of Express that helps us to organize our code, and we'll learn why that's important. We're going to take a peek at some APIs from some third-party systems, other systems, that'll kind of give you an idea of, because our contrived examples and the guided projects that we work on and the sprint challenges and things that we work are pretty small in their scope. But when it comes to developing APIs that other people use, we need to think bigger than that. And so we want to be able to organize our code so that it's easy to maintain and easy to improve upon. And we'll take a peek at some APIs that will kind of open your mind a little bit about why it's important. Because with the small examples that we're using in class, it might seem like it's a little bit overkill, but it's actually quite important. And you'll get a chance to see why. All right, so just taking a quick peek at the guided project. Again, you can get the link to that in the training kit right here at the top where it says guided project. You're going to want to make sure that you have forked that into your own GitHub account and that you've cloned that repo locally so you can follow along with the guided project. And then again, as always, later tonight, I will supply some notes from the lecture in the code. So that'll be hopefully helpful to you. Okay, and like yesterday, the data in our guided project is going to be from a SQLite database, and that's all been set up for us. If we've got some time at the end, I also want to give you some encouragement around being able to manipulate data and create data sources of your own. We are going to have a session in this course around data persistence where we'll learn about databases, and we'll work with SQLite in particular, where you can create your own databases. If you don't have that capability, you don't understand how to do that, that doesn't mean you couldn't create an application that had its own data source. You can use modules with hard-coded data. And so if you're given an assignment where you didn't have a database, you needed to create some data, you could do the same thing. It's one of the things that APIs do for us is they give us kind of a middle layer that can separate us from implementation details on the back end. So you'll find that when we get into the data persistence section, that's quite important, that there be an interface that anybody can write to and it's consistent and it's standard, but it can work with multiple different databases, whether it's SQLite or MySQL or PostgreSQL, Microsoft SQL Server, Oracle, whatever it might be on the back end. But so if we get to the end, we've got some time, we might spend a little bit of time talking through that. But we're going to start off at first talking about REST. If you look in the training kit, in fact, let's see, this is what they want. We'll look at these constraints. Okay, so, and you can find this information online. There's a particular discourse that was written by a guy named Ray Fielding that kind of described the principles of a REST API, and then an almost immediate implementation of those principles to HTTP. And we're going to take a quick peek at that as we go through these constraints. REST is not the end-all be-all for APIs. It just happens to be a very convenient method for developing APIs that work over the internet. And because it's something that people are familiar with, it's a good design decision to develop an API using REST. There are alternatives. Something that's called GraphQL is coming up in popularity. You may have heard of that, and not a bad thing to become familiar with it. It still works over HTTP, but doesn't necessarily follow all of the REST constraints. Even so, it can be very powerful. One of the challenges that we're dealing with right now with the production part of the system that I work with at work, has to do with volume and the number of people that are using the API, and we're constantly looking for ways to optimize that and to make it easier. And one of the things that we theoretically have discovered, we haven't put it into practice yet, is that GraphQL as an alternative could potentially reduce the number of API calls into our servers that we have to process by up to 25%, which would be pretty huge for us. So there are alternatives to REST, but we're going to focus on REST because it's a great skill to have. And like I said, it's pervasive. You're going to find anybody that's got a an API of any significance will have a REST version of that, and that'll include, any APIs that you create that you want to expose in the work that you get to others. If you're working in back-end stuff, you need to strongly consider REST, and it'll probably be what you end up with, at least to some degree. Okay. All right. So if we look at these 6 constraints, these are things that the API itself, these are principles that it should follow if it is to be considered RESTful. And these are basically architecture recommendations or guidelines that you would follow. So this is not a software system. It's not a framework. They're just things that need to be in place if you're going to have an API that's considered RESTful. So client-server architecture obviously needs to work over the network. When you look at HTTP, we have that automatically built in because it works on a client-server architecture where you've got clients on one end and servers on the other, and they're communicating over a network or some medium. Stateless architecture, basically what that statelessness means is, just as an example, if you can think of it this way, in many systems that expose APIs, they'll have an entire bank of API servers that can handle requests coming in, and they'll have in front of those, they'll have load balancers that will determine which API server should receive the request based on which one's the least busy. And some of those might work on a round-robin basis, and others might work off of monitoring the load of each API server and determining, where it should route it. What that means, though, is that your application running in your, whether it's in a browser or whatever application it is on a phone, when it sends a request, an API request, the load balancer might send it to server number 1, and then the response comes back. And then the next request that you send might end up being routed to server number 14. Server number 1 and number 14 don't share information, right? They don't know anything about the past of what has happened. They have no idea of that. And so it's important that a good API like this allow that kind of horizontal scaling where you can increase the capacity of your API simply by adding additional servers. That's what's called horizontal scaling. Without worrying about making the servers all be aware of any given kind of session management, so that when a client sends a request and it goes to one server, the client can send a related request, and it can go to a completely different server and still operate properly. And the way that works is that the servers don't have to maintain any state information about your session on their side. All of the state information is in the API request itself. Everything that is needed can go with the API request. And so a RESTful API will support statelessness so that you can get very good scalability on the server side. And also on the client side, so you can support thousands, if not millions, of clients or more simultaneously. I'm going to skip this cacheable portion because I'm going to come back to it in just a second, and we're going to actually look at an example of what this means, but we'll come back to that. It needs to be layered. Basically, what a layered system means is that your request might need to go through multiple different services before it actually gets to the server. That is the way the internet works today, right? So if you look at the TCP/IP protocol stack, then you know that at the very bottom you've got the IP protocol, and then above that typically is either UDP or TCP. There are other variants that kind of fit in there, but those are the two main ones. And then on top of that, you typically have application protocols like SMTP or HTTP or FTP. When you send a request from a client to a server, what you're ultimately sending, let's say, is an HTTP request. It might go through a number of different caching systems or firewalls or filters or modifiers. And the API, a good RESTful API, will support that and allow that. And that kind of goes along with the cacheable capability. We're going to talk a little bit more about that in a second, as I mentioned. So a good RESTful API will support layering like that. And again, it might seem like these principles were designed just around the way that HTTP works. The way that if you read the paper that defined it initially from Fielding, you'll see that that's not really the case. He just identified good principles and then began to discover and understand that we already had a huge infrastructure that supported this, and it is the internet with HTTP capabilities. Code on demand is an optional constraint that you very often will not see implemented. I doubt that you'll see an API that implements code on demand, or that you'll ever have a need to implement code on demand. But essentially what it means is that the server has the ability not only to respond to your request, but to also send you code that will allow you to handle that response in a way that you weren't aware of before. It might sound dangerous, and in some instances it is if it's not done properly, but this is listed in Fielding's paper as an optional constraint, and as I said, you'll rarely see it. And then of course, uniform interfaces, where every resource should be accessible through a single URL, where we should be able to manage the resources through those representations, meaning the URL, and every interaction with the resource should happen through the URL identifier that we give to it. And again, this is all working the way that we expect REST to work. Self-descriptive messages, so the body contains everything that you need to be able to understand what happened. That's where the code comes in, as well as the body content. And then something called HADIOS, which stands for Hypermedia as the Engine of Application State. A fully RESTful API is something that can be completely managed by an application. So for example, if a client makes a request, what it will get back is a response. And in that response could be a dynamic list of links that tells the application what the URL is that it needs to use to do the next thing that it might need to do, or that it could possibly do. And those URLs might change. They might be fluid on the back end. But a well-designed API using a fully RESTful API will be able to handle that without any problems. And so things can change on the back end, and you don't have any concern about it on the front end. It says here a good example of that is the GitHub API, and if you've got some time, you may want to go through the documentation of that and kind of take a look at what might come back in the responses, and you'll see links that you would use to take whatever the next action is that you need to take in using the API. All right, so let's go back and take a peek at this cacheable part in order to improve network performance. As an example, let's say that I send a request from my client to a server, and the server responds. So, and my request is, get me a list. Get me a list of, we'll take the example from yesterday. Get me a list of all the hubs in the database. And the server responds, and let's say the list isn't small. So a big chunk of information comes back, and it's taking up all that internet bandwidth all the way through, all the different routers and firewalls, and that's going to take a little bit of time. And then let's say that sometime later, I make the same request, but the server is aware that the data that it should send back to me is identical to the data that it's already sent, right? A good RESTful API will allow that data to be cached so that the server can respond. Instead of sending all of that data again, it can respond with a simple response that says, you already have the latest. I'm not sending you any data because you already have it. And it's assuming that that data has been cached. Now, the client needs to be able to respond back to the server and say, maybe I should have cached it, but I don't have it cached. I actually need you to send it again. And we'll take a peek at how that could work. But if we can take advantage of caching, then it greatly can improve the performance of the API, because we get very quick responses, even when the response should be very large. And so a simple example of that, I've downloaded the application for the guided project today, and I actually have it running, so you can see that it's running here. So if I go into my browser, I'm going to open a browser window here, and I pressed F12 in Chrome. That opens the developer panel here that lets me kind of see things that are happening. And I've got the network tab selected. And so what this is going to do is when I make a request, it's going to log the request and the response when it comes back, and then I'll be able to examine it. So this is one of the tools that we can use as developers to see what we're sending and what's coming back from within a browser. There are other tools that we can use, but this is what I'm using for right now. So you'll see right now I've told it log everything that goes over the network. And one other thing that I've done here in Chrome is I've told it to disable the cache. So basically what that means is that built into Chrome as a browser, Chrome manages its own local cache, right? So this caching capability is something that has to be implemented either by caching systems in between, and that layered concept between the client and the server, or the client can maintain its own cache, and that's what Chrome does. And what I've done is I've told it I don't want it to cache any of the responses that come back, right? So if I do a request, we'll say localhost 4000 and API/hubs. You'll see I get this data back, and if we look at this hubs request, you'll see that I got a status 200 back, right? And if I resend this request, I'm going to hit the refresh button here. You'll notice over here on the right, I got the exact same response back. The data came back with the 200, right? And so what that means is that the server found my request and it responded with the status of 200, and it sent all this information back to me. And the second time I sent it, it did the exact same thing again. So now let me enable the cache, okay? And I'm going to re-request, and keep an eye on, I'm going to click on this. Let's see if I can make this a little bigger. Okay, so I'm going to redo the request. And you notice this time the status that I got back was a 304, okay? Not a 200. Now, if we go and look up HTTP status codes, we can come into this REST API tutorial, which is a good site. It's got some really great information on REST. And we look at 304, not modified. It says here, if the client has performed a conditional GET request, and we're going to talk about what that is in a second, not that you really need to remember it, but just to understand it. And access is allowed, but the document has not been modified, meaning the server knows that what it needs to send hasn't changed. The server should respond with this code. The 304 response must not contain a message body, so it should come back completely empty, and thus is always terminated by the first empty line after the header fields, okay? What's interesting about that is we can see that we actually have data displayed here, but it turns out that our Express server complies with that requirement. It sent a 304 back because the data hadn't changed, and it did not send a body back. What we're looking at here is coming straight out of the browser's cache, right? So the browser maintained this cache information because I told it to not disable the cache. And then when it got this 304 response, the browser went to its own cache and then served that data up to the rendering engine here, okay? To kind of demonstrate that a little more, I'm going to go into Postman, okay? And you can see here that I've got this GET request. Okay, and I'm going to go ahead and send the request, and you'll see I got the information back, and my status response over here was a 200. Okay, and if I send it again, I got a 200 again with the body that came back. Now, one thing I want to point out is that Postman and Chrome are two different applications. They don't work the same way. Chrome has its own cache built in locally, and it keeps copies of the information that come in when caching is enabled. Postman does not do that. Postman is meant to be, we have to do everything explicitly in Postman. That's because it's an API testing application, right? So, so whatever it was that Chrome did in that second request to tell the server, don't send the data back if it's not changed. Just tell me that it's not changed. Chrome managed that for us automatically, but here in Postman, it's not happening. So this is how it works. When we look at the response, you'll see that one of the headers that came back in the response is this header called eTag, and it has this value. Okay, now essentially what the eTag header is it's a header that contains a value that identifies a particular version of a resource. This is a really weird version number, but it's essentially what it is. It's a version number. It turns out that this version number was generated by Express. This is one of the things we get by using Express automatically. We don't have to develop that part on the back end because it's built into Express. So Express keeps track of whether information has changed or not. And if it hasn't, then it sends this e-tag header, automatically adds it for us with this value. Now it's up to us to take this as a client, and this is what Chrome does for us automatically, but if we were developing our own client application, we would have to do this. If we wanted to use this version number and tell the server, don't send me the data if it hasn't changed, then what we would do is add a header called if none match, right? So by clicking, I've already added it before because I was testing around with this. By clicking the checkbox, it's going to add this header called if none match in my request. And then I put as its value some version number. And in this case, I want to take this version number. Let's see. We'll get that and then copy it. And then we'll paste this here. Okay, so now I've gotten the version number that came back from Express, and I'm going to send it in my next request in this header called if none match. And what if none match means is it's basically the client telling the server, send a response if none of your responses match this version number. But if you have a response that does match this version number, don't send it to me. Instead, send me a 304 code that tells me that I already have the latest, right? So we're going to go ahead and send this again. And you'll see that we get this 304 not modified response. And when I look at the body, you'll see that nothing came in the body, right? And that's because Postman isn't maintaining a cache, and so it's not feeding that up to me. We saw that body in Chrome because Chrome does maintain a cache, and its response, or what it displayed to the user in the browser, is coming from its own cache, right? So this is just kind of demonstrating how we can utilize this in a RESTful API and how it works. So that, you know, if we've got on the back end a system that does this versioning for us and can honor this if none match header with the versioning, then we can make the API work much more efficiently over the internet. It turns out, again, with Express, we don't have to code any of that. Okay, but that doesn't mean we shouldn't understand how it works, right? So we do want to know how it works, but you can kind of see, you know, what's happening here as we go through that. And so again, when we look at these constraints, this cacheable constraint, it does improve network performance, right? Especially when you're dealing with a lot of data, right? So that's some things to keep in mind. All right. Someone posted a question. Which dost thou prefer, client or server-side router? This is submitted by Sir Knight. That's an interesting question. There's not a lot of context to it, so I'm going to make some assumptions about the question. They're completely different in terms of what they're used for, right? So they actually let me take that back. They actually perform similar functions in that when you're developing a single page application on the client side, when a request is sent, it's not actually sent, if you remember that. It's actually maintained or responded to by the React system that you have in place. Exactly how it responds based on what's in the URL is, you know, defined by the routing configuration and coding that you do. This is very similar to that, right? So it really, in your question, could be rephrased as, you know, which do I prefer, single page applications or client server applications? And again, I'll just say that really depends. What I'll say is that if you remember some of the work that you did with React Router, you had to have client-side routing for the single-page application portion, but when it came time to send a request for data back to the back end to the server, there was also server-side routing taking place, right? So they have very similar functions, but it just depends on where the requests are being, where they're landing once they're sent. And for single-page applications, they're landing in the browser still. They don't actually ever leave the browser. Whereas with client server, it ends up on the server. Okay, so it's a good question. Well, my answer is I don't prefer either one. It just depends on what the project requires. All right. Hopefully that made sense, and it kind of gives you a peek into the vastness of this interface and framework that we call the internet and the web in particular, and how we can take advantage of it to create APIs that are extremely useful and can be very performant. This is what makes it possible for millions of people to use you know, a particular service that's scaling out to that capability on the back end. Okay. All right, so what we're going to look at next is how we would want to and why we would want to organize our code in a particular way. And kind of to set a foundation for this, I want to give you kind of a quick peek at some APIs that I'm familiar with or that I've used before, just to give you an idea of the scope of them. So here I'm looking at an API from a company called Nice and Contact, happens to be the company I work for. This is the API that I designed. And just to give you an idea, that I'm looking at, well, here's the documentation. You can look at it. This API has admin APIs, agent APIs, authentication APIs, something called patron APIs, real-time data APIs, reporting APIs, data extraction, media playback. There's a whole bunch of different APIs, and just within one of them, this is just the agent API. We have different categories. If we look at agent phone, we've got 4 different APIs there. Chat requests have all of these different APIs. We have you know, email contact management has a ton of different APIs. And the point behind this is to give you an idea that, you know, a production API is likely to have many hundreds, if not thousands, of different endpoints. Okay, so far, as we've been developing route handlers for Express, we've been doing everything in a single file. Can you imagine writing code to handle all of these different API endpoints all in one file? Of course, we wouldn't want to do that, right? It becomes intractable very quickly. And so what we're going to look at is a way that will allow us to structure our code so that it's easy to maintain, easy to add new functionality. You can see in our case, in this particular case, and this is modeled after the Salesforce API, we have API versioning that's in the URI itself. So we have 13 different versions of, actually we have more than that, we have 16 now, of this API, and all of them work. And if there's different functionality in a previous version, you can specify that here. Other REST APIs use HTTP headers to manage versioning. A lot of people recommend that. I find that there can be some challenges with that, which is why we went the direction we did here, but still a very valid thing. If you look at the GitHub API as an example, and look at all these different endpoints that exist here, right? Each one of these, like list deployment statuses, for example, when you click on that, and here's all this documentation for this API and a number of different endpoints that are related to that. It's got events and feeds and blobs and commits and tags and trees and limits and assignees. And again, if you can imagine developing code for all of these different endpoints, you're going to want to have some way to manage and maintain that code so that you can have multiple people working on it. You can have multiple versions. You can fix bugs, find where they need to be fixed much more easily, add new capabilities. Here's another one from Oracle's NetSuite. If you go through this API, you'll find that it's quite large. This is the Salesforce API, has all of these different categories and different APIs over here. And by the way, looking at other people's APIs is it's an interesting pastime for a developer. It's something that I draw some inspiration from. I learn how not to do some things because some people just have done some very horrible things that, for me as a developer, make it really hard for me to use their API. And as I'm developing an API for other developers, I know how to make it better. So it's not a bad thing to do. Of course, Google has a vast empire of APIs, as does Amazon and Microsoft and many others that you can go and look at. So that's kind of the backdrop for why we want to learn how to organize our code in a better way, is because if you don't pay attention to that, you'll find yourself in a situation where it's quickly becoming impossible to manage your project. And so what we're gonna learn today is how to do that. And again, the size and scope of our guided project application is small enough that what we're going to learn might seem like overkill. But just bear in mind that these kinds of things, that if we were to really flesh out our full API, we'd want to do this. So we're gonna try to keep that in mind as we go forward. Okay. So question, why do companies share their APIs with the general population? That's a great question. I can tell you, let's take Salesforce as an example, right? Salesforce.com. If you're familiar with them as a company, then, in their history, you'd have to be kind of old like me to really be familiar with their early beginning days. There was a kind of a movement on the internet called application service providers. And so if you were an application service provider, it was kind of a new fad that was happening on the internet that basically, and if you're younger and the internet's all that you've ever known, this is going to seem, like it's ancient, but this is the way that it was back in that day, back in the early 90s to mid 90s. Applications ran locally. They ran on your local machine. You had to install them from disks, whether it was a CD or a floppy disk or in some cases a thumb drive if you were lucky enough to have one. And you installed it locally and it ran locally. But people began to see the power of being able to run applications on the network, on the internet and across the internet. And Salesforce was one of the first ones that really got it right. And what they did was they took a popular class of application called CRM, or Customer Relationship Management. Typically was a database that ran locally or on a local network and allowed you to keep track of all of your interactions with the customer. It was very popular among sales teams, which is why the company was called Salesforce, right? Today, Salesforce is one of the largest software companies in the world, and they're extremely successful. It's not because their CRM software happened to be particularly usable. In fact, their interface for a long time was quite ugly. They were not proud of that, but they didn't care. The people that used it also didn't care, because what they really cared about and what made it an extremely valuable platform for them was that it wasn't just Salesforce's CRM, but it was Salesforce's CRM plus an ecosystem of thousands of other companies that had add-on services that worked together with their product, right? So all of a sudden, it wasn't just Salesforce solving people's needs, but it was Salesforce plus thousands of other companies that were trying to solve people's problems. And now, if I used Salesforce, I could use Salesforce plus something that hooked into my ERP system, and that hooked into my billing system, and that hooked into my contact management system, and so forth. And so that would not have been possible if Salesforce kept their API close to the vest and made it closed. They were an API first company, and by developing API first and making it public, and making it easy, they made it possible for their ecosystem to grow. And that's what made them such a large and valuable company. There are people that monetize their APIs, that charge for the use. And Salesforce in some instances even does that with their own API. And we're looking at models to do that at the company I work at, as well as others. But for the most part, the name of the game is make it frictionless, make it easy for people to use our platform. So therefore we become sticky, right? It becomes easy for people to stay with us because they get huge value out of it. So that might be a longer answer than what you were looking for, but something I'm kind of passionate about. So that's the reason why you find people sharing with the general population. Our API is a way to get around having to use databases like MySQL or Postgres. And the answer to that is no. You still need databases, and we're going to learn about that later in this course. APIs are a way for hiding the fact that you're using a particular database, right? So if your API is well designed, for example, I happen to know that Salesforce largely uses Oracle databases on the back end, on their back end. But if you write software that runs on the Salesforce platform, you would never know that, right? Likewise, if you ran software that ran against my company's platform, you would have no idea what database we're using on the back end. We abstract that. The API is well enough designed that it's kind of a buffer in between. So we can create a standardized interface. It gives us the freedom to make changes on the back end. We can change what database we're using. without really impacting anybody who's already written code to run against our platform. They don't have to change a thing because of that. And we'll learn more about that when we get to the data persistence part of the course. It's one of the better parts of it. All right, let's see here. Okay, so let's dive into how we want to organize our code around this. We're running a little bit behind, so I'm going to kind of step it up a little bit, but I think you'll be able to follow this pretty easily. So here we've got this project that's similar to what we did yesterday. It's a little bit different. You can see that our routes are a little bit different. We've got /API instead of just /hubs. But that doesn't really matter. This just becomes part of our documentation, and anybody that's writing a client to use our API will just need to know that this is what the app it's in. Right? And now we have handlers that will work on a get against that API endpoint, right? And so we've got all these different API endpoints in here, and you can even see this is somewhat long, even though we only have a few. But what we want to do is in our index, similar to how it worked with React, where your index file pretty much just imported your app file, and your app file pretty much just instantiated the app, and then all of your components were in other modules. That's essentially what we're going to be doing here. So if you're familiar with that concept, which you should be, we're going to be doing something very, very similar here. Right. So what we want to do initially is this creation of a server. So we're bringing in Express and creating a server, and then ultimately letting it listen. Right. We're going to take that and take it out of index.js and put it in its own file, right? So what I want to do here is I'm going to create, by the way, what you want to do in order to follow along, after you've downloaded it, make sure you run npm-i or yarn to download all the dependencies and get your application ready to go, and then do yarn server to get it running. As we're making these changes, we're going to have our server running so that we can get into that. Okay. Someone's suggesting that we should take a break now. Not a bad idea. Since we are running a little bit behind, I wanted to kind of get through this, but let's go ahead and take a break, and then we'll come back and jump into this, right? So let me put up a 5-minute break timer, and then we will come back in 5 minutes and then pick it back up. All right. So back again. So what we're going to do again is we're going to take this index file that has all of our stuff in it, and we're gonna kind of break it down. So we want to take the creation of our Express server and put it in a separate file. So once you've got your project ready to go and running, I'm going to create a new file, and I'm going to call it server.js. Okay. And what we want to do is move these things from our index file over there. So the use of Express, I'm going to cut it and paste it. The creation, in fact, the use of our hubs model and the creation of our server and the server.use. Put that stuff in here. And then we will take all of these route handlers, and we'll move those over as well. Okay. So essentially what we're doing in this file is we're creating a server object, and we're configuring it with all of our route handlers and other middleware. And then what we're going to do is export it. Okay, so remember that in the ECMA 2015 standard, it's a little bit of a different syntax. In this common JS standard, which is what we use in Node.js, the way that we export it is we say module.exports equals whatever thing we're exporting. Right, and then in this case, we're going to be exporting our server object. Okay, and the server object was the thing that we created at the top here. And then we go through all the process of configuring it, and then we're just going to export it. Okay, so we'll save that, and then here in index, we need to import it, right? Okay, and then once we get it, then we can start it to listening. Right, so we'll save that, and then we'll see that over here that things are running properly. And then if I go into Postman, and I'm going to get rid of this header here, we'll send the request, and you can see that we're still up and working. I got my 200 and got my data back. Okay, so we're off to a good start. We've got index basically down to the bare bones of everything it needs to do, and then we have server.js, right, doing what it needs to do. Okay, and that's one of the main elements that we want to take advantage of. Okay. The next thing we want to do is we want to be able to take server and keep it single purpose as well, right? So right now it's got all these different route handlers in it, and you can see that there are some differences among them. Well, actually, all of these have to do with one particular type of resource, okay, except for this first one. So this first handler is just for the root. Everything else is /API/hubs, right? You can see it's highlighted here. We've got with an ID, we've got a post without an ID, we've got a delete with an ID, we've got a put with an ID, and they all share that one thing in common. So again, if you can kind of imagine it, we could leave all of this stuff here, but I'll take a pause for just a second, kind of point out that the structure of your API is going to follow very closely the structure of your data. And again, when we talk about data persistence later in the course, we'll have an exercise where we go through, a process of thinking about what the structure of our data should be. And one of the things we want to think about when we structure our data is what is it going to be like to use an API to access this data, right? So how do people logically think through how to access that? And so here in our case, we've got these hubs as part of our application. And right now, all of our route handlers are around hubs. And so you can think that, you know, this is supposed to be a chat application. We might have something called users, obviously. We could have something called messages. And there might be other elements that we want to be able to manage through the API. And each one of them could potentially have, you know, a dozen or more different endpoints that we need to be able to manage and maintain. And so we want to be able to structure everything so that they're separated, that in a way that allows us to manage and maintain them very efficiently. So in this case, what we want to do is we want to take all of these route handlers that deal with /API/hubs and put them in one place where they're all together, okay? So in order to do that, we're going to use a feature of Express that if you go to the Express website, expressjs.com, and then click on API reference, and then 4.x is the version that we have. You'll see that over here on the left is where you'll find all the documentation for the system. Okay, there's Express itself, which you can see that we've already made use of one of these, which is express.json. Here you can get all the information about what express.json is and how it works, as well as something called .static, and we're going to use this thing called .router. Okay, so a router in Express is essentially a container or an object that contains all of the route handlers. So what we did yesterday when we created, in fact, is the way that we have it organized now, when we look at our code, in our base server application, we're creating all of these route handlers, right, which are a combination of a method and a path, and then a handler method to execute with it. We're creating all of these in what you might consider to be the default router, or the single router that we get automatically when we create an application or a server from Express. But we have the ability to create multiple routers, and each one of those can be for a different section of our API. And we'll set them up and configure them exactly the same way we've done this. Right, so we didn't create a router. We're just adding these methods to what we could consider to be the default router. But in this case, in order to separate our code properly, you want to kind of take each section or chunk of your API and create a router for it. So if we were to go back and look at these third-party APIs, for example, if we were to look at, let's take a look at the GitHub one, we could imagine, for example, that there would be a router for all of the Git tags, another router for all the Git trees, another one for the Git ignore templates, and a different router for interaction limits and so forth, right? So each one of these can have its own router that has its own route handlers built inside of it and has its own configuration. We may have different middleware components, which is what we're going to learn about on Monday. We may have different middleware components that behave differently for different sections of our API. And in order to accomplish that, we need to create separate router objects for each one of those and then get them to work inside of our Express application instead of using this default one. So in order to make that happen for us here, we're going to create a router for /API/hubs and then move all of this stuff over to it, right? And the way that you create a router, again, if we look at the Express documentation, is through express.router, and we would call the router function off of the Express object. And it returns to us a new router object. And the way we work with that router object is very much the way that we've been working with the server object so far. So let me demonstrate that for you. So in order to make this work, what we want to do is inside this hubs folder, we're going to create a new file, and we're just going to call it hubsrouter.js. Okay. Now, because we're going to call express.router, we need to bring Express into the application, right? So we're going to create a constant called Express. Okay. And then we'll create a router object instead of a server object. And instead of calling Express like this, we're going to call express.router with capital R. Okay, and that will create for us a router object. Okay, and then once we have that, we can then export it, right? Okay, so then what we're going to want to do in our server file is import that. Give me just a quick second here. Yeah, so we want to do okay, so we're going to import that router into something called hubs router, right? So that's what we're going to be exporting here. So what we want to do now is bring into this everything that makes these, that router work. So everything that has a path that matches that. So it's going to be all of these different route handlers here. I'm just going to cut them and then paste them over here. Okay, so just to go through this again, here we're creating our express, and then we're using it to create a router. And then instead of server.get, we're going to call it router.get, right? So a little trick that you can do, if you right click on that object, you can choose rename symbol. It says you can't rename it. There's another, refactor, I think is what I want. I'm not sure why it's not letting me do that, but we will just do it the old-fashioned way. I'm just going to replace all of these. Okay, so it's very similar to what we did with the server before, but we're just doing it on this router object, right? So we've created a router object, and then we're adding all these route handlers to it, and then we're exporting it. Okay, and then over here on our server, we're importing it, right? Now keep in mind that over here, we have all of these hubs.find and hubs.findById. This is our data model, right? So in order for that to work, we need to bring our data model in. And it was over here in our server file. So I'm going to cut that and then bring that in. Okay, so essentially we've taken all the stuff that was in index and we've split it up now between the server file and then this hubs router file. Okay, so in our server, we've got express. We're bringing in hubs router. We're not quite done with this yet, but we're bringing that in, and we'll take a peek at what we're going to do with that as we go. We're creating the server object that we're then exporting, and that's what gets started over in index to listen, right? And then we're also saying that for the server, for everything on the server, every router that there is, not just the default one, but any router that we're going to add to it, we want this middleware to be used. And again, what this middleware does is it parses JSON on incoming requests into an object on the request object so that we can access it. And by putting it here, it makes it so that every router that we create, and so far we've only created one, but if we were to create others, they would all benefit from this, right? So this piece of middleware is going to be running for the entire server, not just for any given router, right? Okay, so now that we have that in place, in addition to using this middleware, we want to tell the server that it needs to use our router. Okay, so we're going to say server.use. There's a path that we'll put in here, and then our router object, which is what we were importing in this require statement, right? So here we're telling the server that in addition to its default router, we want it to use this router also, right? And then also this middleware that will work for every route handler. Okay, so this thing right here, this is going to be a path. This is basically our way of telling Express that the handlers that are in this router should be called for any method, whether it's a get, a put, a post, a delete, that is in this path. Okay, so now if we come back over here and look, we'll see that all of these have the /API/hubs path in common. So that is our common path. So here we're going to say that for /API/hubs, that's where this router, things are going to be moved over to this router or handled by this router, right? But because we've put this as the default for every route handler in this router, we need to take them out of this, right? So here we're going to do get slash. And here we can do get /:ID. Hopefully you're kind of catching the drift here, right? So it's like we're taking whatever this is and adding it onto whatever this is. Okay, so the server, when it gets a request, if that request begins with this, it's now going to pass that request over to our router, and whatever comes after this will determine which one of these route handlers is going to get it. Okay. So we'll come through and take all of these out. That's it. Okay. Let's see if there's anything I've forgotten here. I don't think so. So here in our router, we've got our data model. We're creating the router. We're exporting it. In our server, we're importing the router. We're creating our server. We're adding our middleware and adding the router. And we have this default, which doesn't apply to this. This is kind of like an absolute path. So if it is actually slash, it's going to call this. If it's /API/hubs/, then it will call this. Okay, so hopefully that makes sense. So I've saved that, save the server, and obviously have a typo. Cannot find the module ./hubs/hubs-model. Let's see. DEL. And that is because relative to this file, the model is in the same directory, right? So I've got the path wrong here. So because we're inside Hubs router and Hubs router is in the same directory as Hubs model, the path to Hubs model from within Hubs router is ./hubs-model. Okay, so now we're back to working again. All right, so we think we're back to working. It should be working. Let's just double check. We'll come back into Postman. We'll execute this call again. And sure enough, we got our response back. Okay, we got our 200 with our data. All right, so I'm going to just give a few minutes for you guys to catch up. Someone asked the question, what is Hubs-model? This is the same thing that we had yesterday, where Hubs-model is our data methods, right? So then here's where we're using connects in order to connect to our hubs.db3 SQLite database. And then in here we have our find method, our find by method, our add method. These are the things that let us interact with the database. Right, so in order for inside our Hubs router, if you look, for example, getting slash is going to do a hubs.find, and hubs is from our Hubs model. It's going to call the find method, right? So we did this yesterday in class as well, and we've got a find by ID method, we've got an add method. In order for us to do that, we have to bring the data model into this router. It's just like how we had to do it in the index. We had to bring the data model in so we could call those methods. Right? Next question. So basically what server.use with the /API/hubs is doing is saying anything in Hubs router, put /API/hubs at the start. Kind of. It's not actually putting that at the start. What it's saying is kind of the reverse of that. What it's saying is when a request comes in for this, send it to this router. And then whatever comes after this, will determine which one of these methods gets called. Okay. I could do this, and just to demonstrate the point, I could also do server.use/API/thing/hubs. In fact, let me just do /thing/other thing. Okay. So I'm using the exact same router for both of these. But if you look at it from the perspective of the server, what the server is going to say is, when I get a request that comes in that has /API/hubs, I'm going to send that request to this router. And whatever comes after that will determine where in this router, what method is going to handle it. Likewise, I'm telling the server, if anything comes in with /thing/other thing, also send it to that same router. Right? So let me save this. Now, if I come into Postman, instead of /API/hubs, I could do /thing/other thing. I get the same response back. Okay. So it's not that it's putting this in front of what's in router, but instead it's using this to determine if this router should handle that request. And if it has this in the beginning of the URL, then this router is going to get the request, and whatever comes after it is what will determine which of these methods is going to process the request. So you're pretty close on that, but it's, instead of adding it to it, it's using determine if it should route to it. Okay. Let me do a quick poll. Let's see. All right, so I'm going to create this poll in Slido and run it. And if you could just answer with a no if you're not ready to move on, answer with a yes if you are, and if you answer no, go back and say yes. I want to give you a chance to go through and catch up. We'll take a few minutes to do that. So I'm just going to wait for probably another 30 seconds. So far, I've got 100% of people saying yes, but I only have 11 responses, and there's more than 100 of you guys. So everyone, please let me know if you're ready to move on. I don't want to leave anybody behind. And I want you to get a chance to catch up in your code. Couple of no's. So as you guys are going through, I'll just kind of briefly go through again. What we've done is taken everything out of index.js except for this server listen, and we've moved it over to server. We're requiring that and exporting that server so that we can import it into index and start it. On the server side, we took all of the routes and moved them into a hubs router. So here, all we're doing is bringing that hubs router in. We're creating our server, adding global middleware, and then here we've mounted, this is what we've done here is what's called as mounting. We've mounted this router to this URL. We've also mounted this router to this other URL. Okay, and then we've also created a handler that is not mounted to another router. It's actually just in the default router. And then we're exporting this server. Right, over here in the hubs, we create our router using Express. We bring in our data model, and then here's where we have all of our methods. We're adding those methods to the router, and then we took off the beginning part so that we could use this router on multiple URLs if we wanted to, but mostly just to take advantage of the way Express works. Okay. Let's see. Good suggestion. Okay, so there you can see both the server and the router file. Thanks for suggesting that. Yeah, Seong Kim, thanks for the suggestion there. I caught it, but you caught it before me, that we did need to change the path of the data model. Change all occurrences. Thanks, Roland. Sometimes when I'm on stage, my brain stops working, so thanks for helping me out there. All right, 24 of you have said you're ready to move on. The rest of you have not answered. I'm going to assume you're ready to move on, so we're going to go ahead. All right. So that's essentially what we do in order to get our code organized in a way that you can see how this can begin to be really handy. And there's some other aspects to dealing with routers that we're not covering in this course, but if you go and read up on it and study it, and for those of you that are looking at the code, I apologize. I want to pop over here to Express and look at, there's basic routing, and I think there's an advanced routing guide that will talk about some other methods. And if you go and look at, and I would recommend, this is one of the ways that we learn from each other, is by looking at each other's code. You need to get really good at looking at other people's code, right? So if you go and look at other people's implementations of Express-based APIs, you'll see some really powerful and interesting methods for organizing the code and using routers. And there's a lot that you can learn about Express by looking at the way other people use it. We're just touching kind of on the surface here and giving you a good foundation so that you can then move forward. So I do recommend that you take advantage of an opportunity to look at some other implementations. All right. The next thing we're going to do is just talk about query parameters. So we've talked about using route parameters where you use, like this, where you put a colon in front of a portion of the route. And if you look at, for example, this nice and contact API under email, there was one in here that I saw. In fact, you can look at this one here. You can see these parameterized portions of the URL, agent sessions, and then what they have in the curly braces here is a session ID. That means that this URL, it needs to be handled by a particular route handler, but portions of the URL could be different. They could change. They're dynamic, right? So a session ID and a contact ID. But by parameterizing those in the URL, we can make the handler behave differently. We've also looked at how we can send data into a request using the body, right? So the next thing we're going to look at is how to pass data into a request using query parameters. So to kind of demonstrate this, I'm just going to do a quick search. And what I'm going to search for is for query string parameters. Okay, and that brings up a list of responses from Google. But if we look at what Google did, it took my research request and turned it into this long URL, right? So I'm going to copy that to my clipboard. I'm going to come over here, create a new file, and paste it in, and then kind of break it down, right? So we look here, we've got the protocol. This is actually called the scheme. Then here's the host name, and then the URL, the path, and then there's this question mark, right? And then after the question mark, we've got a series of name value pairs. So here's a name equals and then some value followed by an ampersand or an and symbol, some people call it, right? And there's another name equals and then another value and then another and sign or ampersand and then another name equals and another value, right? And so we can kind of break this down and see that there are different query string parameters that can be passed in. They're not part of the URL. They're not part of the host name. They're not part of the path. They come after that, and they're separated from that with a question mark, and then a name value pair, and then an ampersand, and then another name value pair, and so forth, for as many as we need until you get to the maximum URL length, which depending on the browser, they're different, and some servers have different URL links that they will support as well. But they're typically quite long, and typically if you're hitting that, you probably have a bad architecture and need to consider redoing things. Okay, so hopefully this kind of helps you understand what a query string is. And if we support them in our API, then we make it possible for clients, for software developers that are using our API, in addition to parameterizing the path or putting parameters in the path and adding data to the body, we can allow them to pass information to us in a query string. And there's some nuances to how you would choose which method to pass data in. So if we look at this API, this is basically, according to Rust principles, this is a URL that represents a single resource. Okay, in this case, it's a resource that actually takes some action, but it's still a resource. And so even though there are portions of this URL that might be different, they all go to identifying a particular resource. Whereas looking at these parameters, these are meant to change. They're not part of identifying a resource. They're actually part of controlling or manipulating or influencing how the handler behaves, right? And we're going to take a quick peek at how that works in our own API that's been created for us here. But what happens is that Express will take this name value pair collection and turn it into, similar to how we get a collection of parameters in the URL, the query string becomes an object on the request object that is an object as well, that has these names as properties and then these values as their values, whatever they happen to be, right? So if we were to take a peek at that, I'm going to move on from this. So let me close that and that, and then we'll come back over here to this router. All right. So to kind of demonstrate this, if we were to take a look at this particular endpoint here, okay, this get method inside our router, we can see that it calls the find method in our model. And if we look at the find method, you'll notice that it takes a parameter called a query. Okay, so this is where we can control what find returns to us. And find sets some default for some values. Okay, and it tries to read those values by destructuring them. That's a JavaScript feature. If you're not familiar with it, you should become familiar with it. Out of the query parameter. So this is an object that could contain any of these properties with the value. And if it does happen to contain any of these properties, then that variable will take on the value that's in the object. If it doesn't, then it will take on a default value, okay, of 1. You'll notice that there's a value called limit that is set to 2. By coincidence, or maybe not, you'll notice that when we did our queries, we always came back with 2 responses, right? And that's because by default, the find method is setting a limit to 2. You can see here that the database request out of the hubs table is establishing a limit of whatever the value of this is. And if we don't set one, then the value is 2, okay? If we look at our router, what that means is that we can pass in whatever comes in on the query string, right? And this has already been set up for us. So on the request object, there's the query object that can contain anything that we pass in, but if it happens to contain any of these things, then by passing it into our find method, we're going to be able to control what find does. Okay, so as an example of that, if I go back into here, and I can set query parameters. I wonder if I haven't actually tried this in Postman. I'm going to try to do it this way. Limit equals 5. Okay, so here I've established that I'm done with the URL, and now I'm creating a query string, and my first name value pair is limit with a value of 5. Yeah, and so now you can see I get back not just the 2, but 5. Okay, so if we were to come back over here and in our router, just for fun, do log rec.query. We'll save that, and then go back into Postman, resend our request, and then come back. You'll see that this is the object that is being saved on the rec object, right? And also to kind of demonstrate how that works, if I come back over here and then I put an ampersand and the thing is equals important, right? It's just an arbitrary name and an arbitrary value. And I send that in. I still get my 5 back because my query string includes limit, but it also includes this thing called the thing is, and you can see that it's part of our object. And that entire object is being passed to find, but find is only looking for things called page and limit and sort by and sort order, right? So if I were to change the sort order to descending and look for page number 2, right, you can see here it's creating something called an offset, which it's using when it does the actual query. And that offset is the number of things we're looking for times whatever the page number is, right? So basically saying, give me 5 things off of whatever the page is. So if I were to say page equals 2, okay, now you'll see I get 6, 7, 8, 9, and 10. And if I do I think it's DESC. I'm not actually sure. I think it's DESC. Sort dir. Yeah. So now I get 15, 14, 13, 12, and 11. So basically it went to the end and gave me the last 5. Right? So if I say, take the page thing out. Okay. So that's the actual last page. The previous one was the second to the last page, right? So you can see how we can use query parameters to kind of control how things work in our API. Question, where would you pass a query string in when you do an Axios call? Axios will have different methods for establishing what the query string ought to be. I can point you to that, where that's documented when we have another break here in just a little bit. But it definitely has a way for you to do that. You can compose it or you can include it, and it's got a couple different ways of doing that. But I'll point you to some documentation that'll help answer that question. Okay. All right, let's see where we're at here. All right, we're going to take a 5-minute break and another one, and then we'll move on to a concept called subroutes. We'll give you a little bit of an exercise that you can do on your own, and then we'll look at some of those results. And then if we have time at the end, we may talk a little bit about some basic Java skills, and I've got some thoughts on. You may have noticed that, for example, in the hubs model, not in the model, but yeah, in the model, some of these things are using async await, and some of them don't. And that might be interesting for you to kind of understand. And so I've got some thoughts around that I can share and help you understand what async await is. It's a different syntax for promises. So let's take a 5-minute break, and then we will get back to it. All right. All right, so let's talk very briefly about, I think, a concept that I'm hoping is probably already pretty apparent to you, simply by the fact that we've got some URLs in this router that are just a slash, and others actually contain a portion of it, right? Depending, again, and this is all being driven by the structure of your data model. Depending on that, you may have you may have APIs that start with /API/hubs, but have more after it, right? That need to show up in here. So as an example, again, if we were to come and look at one of these third-party APIs, let's take a look at the GitHub one. So you can see here that they actually tell you which parts are parameterized and which ones aren't. And I'm not sure how, obviously, how they have their code organized, but they may have, if they were using Express on the back end, which they may or may not be, if they were, they might have a router for that, right? For /repos, you know, or maybe just for /repos, right? So inside of that router, they would have a post handler for /:owner//repo/get/refs, right? So let's take this as an example, and this is not at all going to fit in with our application, but you'll get kind of the idea. We could do like this, but let's assume again that this router is being mounted at /repos. Then our route for this post object would be like that, right? So this again would be the portion that comes after the mount point. And the mount point is where we specify our use. So we could, for example, say, and then here we could do a rex, comma res, and just for simplicity's sake, we'll just do, actually we have to respond, so we'll do okay. So here we're saying if we do a post to this URL after any of these, but /repos being one of them, then we're gonna just send back this yay you did it, right? So I'm gonna save this, and I'll save this, and then if I come into here, create a new okay, and then for the owner, we can put in number 1, and maybe for the repo, we can put in 1, 2, or 2, 3, 4. Okay, so if we're passing in this URL, because it begins with /repos, that's going to cause it to go to this router, right? And then within this router, because the rest of the URL has this format, where we've got slash and a parameter and slash and a parameter followed by /get followed by /refs, that's going to match this. And because it's a post, now it's a post, because it's a post, it's going to match this. So, you know, essentially Express is going to say it's a post. It has this beginning portion, so it goes to this router, and it has this end portion, therefore execute this handler, which is just going to return, yay, you did it, right? So if we send that, then the response we get back is, yeah, you did it. Okay, so hopefully that makes sense. I think mainly wanted to kind of point that out because this can look a little bit minimal or homogeneous as if it were that way by design. It doesn't have to be. It all, again, is going to be driven by the design of your data and what APIs you need and how you choose to organize your code, right? Okay. Question, are query strings automatically set or are they custom? You can, again, when you create documentation for your API, which by the way is as important as the API itself, in my opinion. Some people talk about self-documenting APIs. I've got an opinion about that. I think that the APIs need to be very easy to understand without reading the documentation, but you have to supply documentation. If you don't have examples and sample code in particular, then you're going to run into trouble. And you'll notice, this is a pattern that we followed in our own API here. We've got a bunch of different documents that explain certain concepts, but within the code itself, we actually have, this is all a Swagger-based documentation where if I log in, I'm actually able to try it out. But for each one of these different languages, we have sample code. Right. So we've got Scala, Python, JavaScript, of course, that gives you an example of how to use it. And so this is critical part of it. So you need to make sure that you document it. Okay, so my point there is that if using query strings as part of your API is an important part of making it work and being successful with it, then you get to decide what query string parameters should they be able to send in, and what should your API handlers do in response to them. So they're completely custom, and whether or not the developer who's using your API sends them in, depends on what they're trying to do. And if they're required and they don't send them in, then you should respond with an error. For the most part, parameters, and that might be the case. By the way, there's one other method, and we'll learn about this a little later. There's one other method to get data into your API handlers, and that is through the headers. So you can allow developers to create headers to pass information in, whether it's for authentication, and we'll learn about that later in the course, or for other reasons. Whether or not they do will depend on whether or not they understand it, whether it's required. So they're completely custom, and it just depends on what your API is doing and what is required to use it. So question, why was the one post method used for /repos and not the other post? And I'm not really sure I completely understand the question, but I think I do. So to kind of demonstrate, if I did /repos just because that's what was in the GitHub example. But because we are mounting this one router to all three of these root URLs, we could do it instead of /repos, we could do it with this, right? So if I go back into Postman and replace that with that, then we'll get the same result. And likewise, I could do /API/hubs, right? Because that's another mount point for that same router. Okay, so it was just arbitrary. It was just me following an example through. But because we're mounting that one router to all three of those root URLs, any of them will work. Okay. All right, what I want to do now is give you a brief assignment, to have you work through this, and I'll do that same poll to give you a chance to indicate whether or not you're done. But what I'd like you to do is create an endpoint that allows you to add a new message to a hub. Okay, so to kind of give you an example, I'm going to actually, I should have done this before, but when we look at our data model, one of the things that I'll post this in Slack so that you guys can just copy it in without having to type it all in. Part of our data model says that we have a messages collection for any given hub. So if you identify a hub and you try to get its messages, it'll bring back messages for that hub. Okay. And so for this, we're going to do well, I'm actually going to do this. I'm just going to cut and paste this from my example notes. And this is going to be an async await syntax, so don't be thrown off by that. We're going to cover this in just a little bit. But essentially, what this is, it's a get handler for getting messages. And then in our method, we're calling the find hub messages using an ID out of the parameters. So this is going to be a parameter. And then if it returns anything, then we're just going to respond with those messages. And if the ID is wrong, we'll respond with an error code. And if something goes wrong in the server, then we'll respond with a 500, right? So I've saved that, and just to test it, if I come into my get, I could see that one of my hubs is 20, for example. And so if I wanted to do get slash API localhost slash API slash hubs slash 20 slash messages. It says there's none. Let me do one. Okay, so for hub number one, these are messages that exist in that hub, right? So the API is working there. So I'm going to post this in Slack. Okay, so you can put that in your file. And then what I'd like you to do next is create a route handler that will allow you to add a new message to a hub. So this will let you get them, okay? But similar to what we did yesterday, and just as a hint, think about what HTTP method we use to create things and what you have to supply and how you supply it in order to create them, right? So if you look at this post, there's some hints here for what you're going to need to do. So you want to create a route handler that'll let you add a message to the messages collection for a hub, okay? And because it's going to be slash API slash hubs, it's going to be in this same hubs-router file, okay? So let me put up, well, actually, I'm just going to time for 5 minutes and then let you guys get to that point. And I'll let you know when we get to 5 minutes. So I'll go on mute for 5 minutes and then let you guys do that. And let me actually put the assignment in Slack. Okay. All right, 5 minute timer starting now. Okay, we'll go for another couple of minutes. I've opened up the poll in Slido. If you could use that to kind of indicate whether you're ready to move on, that'll help me to know. If you need more time or you'd like me to go over it, then please click no. If a good portion of you are saying no, then I'll go over it so that we can move on to the next topic. Okay, we still have a couple of folks that are not quite ready to move on, but what I want to do is kind of start coding through this example. For those of you that have finished, if you've got a finished example, somebody post it in Slack, and we can use that as a starting point. If I don't see one in Slack, then I'll start coding it by hand, but I'd love to see somebody's example in Slack if you've got one done. Nobody wants to step up, huh? All right. All right, so let's just dive into it then, and I'll kind of take you through it. So again, we're going to create a method for creating a message for a hub. Okay, so this is going to be a handler that's added to our router, and of course we're going to use the post method, right? And because it's going to be for a specific hub, we need to get the ID passed in, and then our target is the messages collection for that hub, right? And of course, we need our request and response objects and our callback method. And I'm gonna code this using async and await, and then after we're finished with this, I'll go back and go through what async and await is, right? So this is going to be an async method. And because it's a post, we know that the message info itself is going to come in from the body, right? And if we were to take a look at Postman, when we did a get for messages, you can see the structure of it, which essentially is the hub that it belongs to, and the sender and the text really is all that we need to provide, right? The hub that it provides, that it belongs to, is going to be in the URL. Okay, so the message that we want to receive or retrieve is going to come from the request body. Okay, and we also want this message info object, which we're going to use to create the thing, to contain the hub ID, right? So now the body itself, we could pass that in, but we really want to pull it from here, right? So there's a syntax that I'm going to use, which basically says I'm going to create a new object, and the stuff that's in that object is going to be, basically all the things that are in the body, plus an object or a property called hub ID. And the hub ID is going to have a value that's going to come from this parameter, right? So that's going to be off of our request object, the params collection, and the name of our parameter is ID, right? Okay, so essentially what this is doing, this is what's known as the spread operator. And basically what that does is it says, take all of the properties that are in this object and make it as if I had typed them in with the name of the property and a colon and then the value of that property. So it's just going to take all of that stuff and spread it out into my object. And then after that, I'm saying put a comma and add one more property to it called hub ID. And the value of it is going to come out of this, right? So the message info object is going to contain all of that stuff. All right. Now, because we're doing async and away, we're also going to use something called try and catch. And we'll go through what that is when we talk about async and await. But in here, we want to create the message and then get it back, right? So what we're going to do is we're going to call hubs.addMessage. We're going to pass in our message info object. Okay. And then we'll set our status to 201 and we'll pass back the message that was created. And again, the main reason we do that, even though the data for that message was passed into us, we want the client to know we got it and what we created is what they told us, right? So we're going to pass it back to them and that way they can verify that what we've done is the right thing. If there's an error, something that happens in the database system, then we're going to get this, it's going to be thrown as an error. We'll catch it here and we'll just log it to the console. And then we'll also return it in the JSON object. Okay, that's pretty much it. Okay, so we're going to extract the message info from the body and add to it a property called hub ID, and then we're going to pass that object into the add message. If we go over here and look at that, the add message method takes a message object and then it does an insert. And then this insert returns the ID, and then we're going to use that to actually get the message that was inserted and return it. And that's why we're assigning it to this variable, and then from there we can send it back to the API caller. Right, so I'm going to save this. Okay, and so now if I go back into Postman again, I need to specify text and a sender. And so I'm going to do a post localhost hubs /1/messages. We're going to create a body. It's going to be raw JSON. And then text is going to be I'm not very creative, so I'm going to do that. And then the sender is going to be someone. Okay. So again, the text and sender. Right. So if I send this, then you'll see we get the message back. And it says it went to this hub. And then there's the sender and the text. Okay. All right, that's basically it. We're out of time. This next thing that I want to talk about, it's only going to take me a few minutes to go over it, is completely optional. This is not part of the class. You're welcome to drop off now if you want. You can catch this in the recording later. But I'd like to keep the recording going so that we can capture it for those that will be interested in it. And I want to talk a little bit about async and await. It wasn't in the training kit. but I know that this is a topic that confuses JavaScript developers all the time. And you will see, this syntax in a number of different places. And I've not seen any curriculum that really covers it. When I taught front end, I spent a fair amount of time teaching about it, and the students indicated that they really appreciated that. So I want to take just a little bit of time to help, and I'm not sure if my brother covered this with you or somebody else did, but if you want a little refresher, then feel free to stick around, and I'll take another 5 minutes or so and kind of go over what async and await is. So I saw somebody post in Slack that they much prefer async and await as a syntax. I do as well, and I'm going to explain why here in just a minute. So I'm just going to pause for just 10 seconds or so. Let those of you that want to drop off, go ahead and drop off, and anybody that wants to stick around and hear this, then feel free to do so. All right. So with async and await, async and await is related to something called promises, but I kind of want to go back a little bit and talk about JavaScript and something called asynchronous code. So I'm not going to go as deep into this as I could. I've been toying around with creating a YouTube recording that I could kind of point people to kind of explain it. You can get a lot of this stuff. Oh, sorry, Sasha. I appreciate you bringing that up. I forgot that there's going to be a Halloween contest after this as well, a costume contest. So I'll try to keep this really brief. I don't want to interfere with that. So there's this concept of asynchronous code, which basically means that you make a request for something to happen, and that request returns immediately, even though the thing you've requested isn't finished yet, right? So synchronous code means you make the request and it doesn't return until it's finished. Asynchronous code is kind of important because sometimes there are things that you request that take a while. And if you're not careful, if the request doesn't respond very quickly, then it'll block your code from continuing on. It'll stop and wait. And that becomes a challenge because your code could not behave properly, especially if it has a user interface. All kinds of problems can occur. So asynchronous code is something that you want to have when you want to make a request that is long running or that has the potential to be long running. Database access or anything over a network has the potential to be long running. And so there are many other instances where that could be the case. In order to handle that in JavaScript and other languages, they have an entire threading model that uses multiple threads in the operating system as a feature in order to allow you to manage it. But dealing with those threads, so you basically launch a new thread, and that thread runs independently of yours. So you get to continue on while it also continues on. But in order to have that work safely, you have to manage something called race conditions. You also have to manage deadlock conditions. What if you've got two different threads that are using the same resource and one of them's changing them before the other one gets a chance to read it? You can create really weird artifacts and behavior in your application. And so with JavaScript, the entire thing is single threaded. There's only one thread. That prevents us from having to worry about race conditions and so forth. But we still want to have the ability to have our application continue on even though we've got a long-running method. And this is what callbacks were meant for. So basically, when I go to make a request, I can give a function to the request and tell it, when you're done, call this function. And that allows me to handle and to know when it's finished. But in the meantime, I can do other things, right? And then my other things will get interrupted by that thing calling my callback. The problem with the callbacks is that it can get very unwieldy, and you end up in something that's called callback hell. And again, I'm not going to go into the details about that, but if you Google callback hell, you'll find all kinds of examples of that and why it can be a bad thing. In order to alleviate that, there was a company that created a system in JavaScript to allow asynchronous code using something called promises. And basically what a promise is when you call a long-running function that returns a promise, it immediately returns with this object that you can then use to tell it what to do as a callback, right? So it's using the same method underneath, still using callbacks, but it's just a different syntax that prevents a really ugly callback hell that makes it difficult to read. So essentially, you get this promise object back, and then using that promise object, you say, here's a method I want you to call if you're successful. Here's a method I want you to call if you're not successful. And then, in a similar fashion, you get interrupted by it calling those methods on either one of those situations. And so you see that up here, for example, right here, this update method is something that returns a promise. And off of that promise, you can call the then method, where you pass in a function. This is basically a callback function. You're basically saying, call this function when you successfully finish this update. And then with the .catch, you pass in a different function and you say, call this one if there's an error, right? And so you're immediately passing these in using the promise that comes back, which is returned immediately, even if the update isn't finished. But as soon as the update is finished, it will call your method, right? That's exactly all this is. It's just like a callback, right? Using async and await does the same thing. It allows you to specify code that should run on success and code that should run on failure, but it does it in a way that's a lot more intuitive in my mind. So if you look at this method, we're specifying that our method that is the handler is an asynchronous method, which means that it's going to be run on its own thread. And we've got this try catch block. And in the try, we're saying, call this long running function. But even though it returns a promise, we don't want you to return immediately. We're going to wait. So don't return until you're actually done. And when you are done, don't return the promise itself, but instead return this thing, return the value that find hub messages is supposed to return. And we're going to assign it to this variable. And then we can continue on. This is the code that we're going to execute when this finishes, which makes sense, right? So it just looked really intuitive. You're just saying, do this, and when it's done, do this. We still want all of this to run on its own thread because this could be long running. And that's what async does. Async puts it on its own thread. And so here we're saying, even though it returns a promise immediately, we don't want that to happen. We're going to wait until it finishes and then take the return value and assign it here. And then we're going to execute the rest of this code afterward. And then we're also saying, if there's an error condition, drop down to this catch clause and run this code. Right? So this is going to finish one way or another. It's going to finish successfully or it's going to finish with an error. And if it finishes successfully, it'll take the value that comes back from this function and assign it to this and then continue on with our code. And if it finishes with an error, it's going to drop down here to this catch block and run this. This is, to me, far more intuitive, right? So that's essentially all async and await does. It's exactly the same thing. I could do the exact same thing here with this hub update. You can convert this, and in the notes that I'll give you after I'm done tonight, I'll have a number of different examples in our router that use async and await, and then in comments I'll have the then catch, or what's known as the thenified version of the syntax. And you can make your own opinion as to which one you prefer to use, but again, they're just the same thing. If I were to do a thenified version of this, instead of assigning the value here, what I would do is I would just call this, and then afterwards there would be a .then like this, and this messages would be the value that we're going to pass into the function in .then, and the body of that function would be this stuff. Okay, so it's essentially the same thing. What you're seeing here and what you're seeing here are the same thing. It's just a different syntax. Okay, so hopefully that's helpful. I'll attach some additional notes and some references to some other things you can read up on, and there's all kinds of information out there. A lot of different people try a lot of different methods to explain it. A lot of it's confusing to me, but you'll find something that'll help you get there. And if you've got other questions, feel free to hit me up. I'm happy to add additional information and some samples that can kind of help make more sense out of it. So hopefully this has been helpful. And with that, I'll finish the lecture and let you guys move on to the contest, those of you that are participating in that. And hope you have a fantastic weekend, and I will catch you guys on Monday. Thanks, guys.